So fourth day, fourth design pattern, we will be unraveling. We have already been more than halfway through this boot camp. What was the design pattern that we learned yesterday? It was decorator, right? All of you just write it in the chat box. What is decorator pattern according to you? And when should it be used? What kind of problem it addresses? So I just want to know what is your high level overview based understanding of decorator pattern? Just write it, your personal responses in the chat box. I'll see and that'll give me a feel of how well probably you understood it. Let's everyone do that. Okay. So exponential combinations of classes. Yeah, that is a problem that it solves. Almost all of you are saying the same thing. Okay. Yeah, that is the real problem that decorator pattern solves. And it solves it very beautifully, isn't it? I mean, you can decorate an object with some other behavior. I would not say some other behavior. Basically, you can add a behavior on top of existing behavior. So if, let's say there is an object called as person, and that person can probably just walk. Okay. Now you can decorate that object with some other object of the same super type so that now that person can walk fast. And that would be equivalent to actually running. So it's like you enhance the capability of underlying object by decorating it with some other object. And you do all that without disturbing the underlying object. You do not touch their class. Okay, so that is the most beautiful thing about it. Okay, just explore some uses of decorator pattern. Like you can look at how buffered reader class is implemented in Java. If you go through it, you will see how beautifully they have used it. Okay, cool. So we are going to talk about something new today. Let's say what we want to do is we want to design a very simple thing. We want to design a cricket scoreboard. Okay, when I ask you to design a cricket scoreboard, I would want you to focus your attention only on the cricket scoreboard. I mean, do not think about the entire ESPN Cricket Info. Do not think about commentary. Do not think about a lot of other things because if you include all those things, the case study will become much bulky. And the thing that we are trying to hit hard, we might not be able to do that. So we are going to just focus on the cricket scoreboard thing. Now, let me tell you the requirements that we face. So, of course, if I talk about cricket scoreboard, there'll be different things inside it, but I'll focus on the most important data that is there on cricket scoreboard. So even right now, IPL is going on. And if you look at the scoreboard that is displayed there, what are the most important data? What are the most important data of any cricket scoreboard according to you? Total score, very good. So the first thing is score, which is an integer. And what is the next thing? The next thing is wickets. Yeah, that is also an integer. And what is the next thing? You also have a count of overs, isn't it? Yeah. So that can be a float or a double because you have 2.3 overs, 3.4 overs. So you have overs. So let's focus on these three things for now. Of course, there can be many more things like who are the current batsmen who are batting and a lot of other stuffs like what was the speed of the last ball that was bowled, all the sorts of things. What is the remaining number of reviews, DRS reviews for this team and that team? Let's not focus on that for now. Let's only focus on score, wickets, and overs. This overs means elapsed overs, of course, that how many overs have been bowled. Okay. So imagine that you are managing a piece of software that contains these data and is the owner of these data because you are building cricket scoreboard. So of course, you have some sort of mechanism through which you are able to update the score, wicket, and elapsed overs in a real-time mode. So that could happen by so many means. Maybe there is an external API and you call that API at some regular interval and pull that what is the current score, wickets. So where from the latest data about score and wickets and elapsed overs is coming, we are not worried about that. We are just assuming that it is somehow coming. Okay, so let's assume that we have a class called as cricket scoreboard, and that class every time contains latest values of score, wickets, and elapsed overs. Let's have that assumption. Now, what we want to build is we want to probably build some custom analytics. Okay, now see, there can be different forms of analytics that I would want to seek. So let's say the first kind of analytics that I want is run rate. Okay, so if I want that I have run rate analytics, and if I want it to be real time, then of course this thing has to pull in the data from this thing. Okay. Similarly, let's say another kind of analytics that we have is predicted score. So these days, predicted score is also calculated. And of course, that calculation logic must be very complex rather than just trivial. To compute run rate, you just have to do a division. But to compute predicted score, you might have to do a lot many other things that may be AI ML driven also, which I mean the internal logic might be quite complex. But at the end of the day, this also has to pull data from here. And then let's say you have one more analytics called as top discussion. So this is like a commentary kind of thing, a loose commentary kind of thing, which probably pulls in the data from here and performs some discussion that, hey, the current score is this, wickets is that, and people can probably, use that data to tweet something or do whatever they want. It's up to them. At the end of the day, what I want to suggest is that we have three components. We can have much more components which are going to require data from this class called as cricket scoreboard. Okay. Now, how do you think this can happen? So let's first boil down this problem to real world problems that we get to see. So think of it in this manner. How many of you have ever subscribed yourself to a newsletter? Anyone who ever subscribed yourself to a newsletter or to some blog like Medium blog or anything, or YouTube channel, anything? Okay. How does that work? How do you think it kind of works? So let's say there is a YouTube channel. Okay. And now there are multiple people who have subscribed to it. So let's say there is a person A, there is a person B, there is a person C. So these are the persons who have subscribed to this YouTube channel. Now, if somebody subscribes to something, then that person would want that it is able to keep itself up with the latest updates. Okay. How can that be done? So one way is that this can continuously pull data from here. I mean, with a regular interval of maybe 1 second or whatever that time period is, with that interval, A can keep pulling data from here. B also can keep pulling data from here. C also can keep pulling data from here. So basically, when you're pulling data, what is it that you are getting? You are getting some sort of notification that, hey, this video has been uploaded on this channel, or this short has been uploaded on this channel. So these kind of notifications, they are called as pull notification, where subscribers have to pull the notification from the publisher. Okay, so here this YouTube channel can be thought of as nothing but a publisher. It is a publisher, and these things are subscribers, and these subscribers are pulling the notification. Okay, does it make sense to everyone when I say this term pull notification? And do you get what is the essence of it? Yeah. And are you able to see who is the publisher and who all are the subscribers? Okay. Pull notification is one mechanism, but these days, which kind of notification is popular? It's push notification. How does push notification works? It works in following manner. It says that the subscribers do not have to worry. Publisher, whenever it sees that something has changed, something has been added, then it is responsibility of publisher to notify that to all its subscribers. So which one do you think is better, pull versus push? Which one? It's very easy to say, no, that push is very easy, but why? You can mention your reasons in the chat box. Reduces unnecessary work. Very good. You know, let's say there is a YouTube channel on which a new video is uploaded only after 30 days. Now, if these subscribers are requesting for new update or trying to pull the new data every second, then that is going to be a lot of redundant work. That is going to burden this server with so many calls. Imagine if a particular subscriber makes 10 calls in 1 second. And then if your number of subscribers increase, then the number of calls is going to get incremented by, it's going to get incremented linearly, but there is going to be a tremendous load on that server. So this kind of mechanism where you are continuously trying to pull data from somewhere is not a scalable way to get things done. More scalable way is to do push notification kind of thing. Okay. So now that the idea of pull versus push is clear, if you think a little bit about the scenario which I had mentioned, if somebody has to design a brute force solution to this, how would he design it? Can you think about it? So what he would do is he would say, let's go ahead and write some class. So let's say there is a class called as cricket scoreboard, which has these 3 fields. Okay. And now there is a method called as update score. Now, this method is somehow invoked from outside. How it is invoked, I don't care about it. As I told at the beginning also, it is somehow invoked and it is sent with the latest values of runs, wickets, and overs, which we assign to the instance variables of this particular class. And then we have a getter for runs, wickets, and overs. This is all that we have. Okay. Now, if you think about it, if this is the cricket scoreboard class that we have, and now there are so treat it like a publisher. Okay, so it has latest data. And now there are some other classes that probably has to depend on it. How would they work? How would they function? Let's just think of it. So let's say I want to write a run rate board kind of thing. Okay, I want to write a run rate board, which has to show just the run rates. So what it can do is that first thing, it needs to have a dependency on that. So it'll have a field private final cricket scoreboard. Okay. And it can be injected inside it by a constructor. And now it can have a method inside here, which can say, let's say that method is public void update. Okay. Now, the responsibility of this method is to continuously keep on fetching the latest data from cricket scoreboard and use that to show the latest run rate. So for that, what it can do is it can probably run an infinite while loop. And it can say that, hey, what I'll do is I'll keep the values of private int runs, wickets, and what was the type of overs? It was float. So it would say, I'll keep these fields for now with me. And now what I'll do is I'll run this while loop and I'll check that what is the value of runs that I am going to see inside this cricket scoreboard. So for that, I can call cricket scoreboard dot get runs. Okay. And if it so happens that R, which is runs, is not equals to the current runs, it means I need to update my runs. So I would say runs is equals to R. So as you can see, what I have done is I have fetched the current value of runs from the cricket scoreboard. And if that is not equal to the current runs, that means the runs that I have right now is obsolete, is basically outdated. So I basically update it. Now, whatever I have done for runs, I can do it for other fields also. I can do it for wickets. I can also do it for overs, right? So the same thing can be done for wickets, and exact same thing can be done for overs. And after that, you can have some logic to probably persist those latest data inside your database. So now you'll persist that latest data, whatever you have fetched, in database. Of course, if the value of runs, wickets, and overs have not changed, then there is no need to make that database call. So for that, maybe what you can do is you can have a Boolean variable. Let's say there is a Boolean variable is updated, which is initially false. And now whenever you see that this thing has happened, you can make is updated as true. And you can do this same thing in case if wickets was updated or overs was updated. And now basically here you can have a clause that if is updated, then that means that either runs or wickets or overs have got updated. So in this case, you can talk to DB. You can talk to your database and supply it with the latest value of results. So this is one very brute force implementation of our run rate board, where all that we are doing is we are pulling the data. Okay, is it making sense? Does the code go in line with whatever we had discussed so far? Yes or no? Yeah, a very trivially implemented class, right? Okay, so the first con of this class is that it is inefficient. This while loop, it'll just keep on, it's like a spin lock. I mean, it's going to run. It'll keep on running. And most of the times it will see that nothing has updated. Okay, so that is one bad thing. We need to fix it. So what is the first idea that comes to your mind? The first idea that might come to your mind could be something like this, that, hey, instead of this guy fetching data from this guy, what about cricket scoreboard can have a reference to that thing? So cricket scoreboard has a reference to run rate board. Okay, and now it can be injected inside the constructor of this. And whenever update score happens inside cricket scoreboard, what it can do is it can pass all these data to that run rate board. And then that run rate board will do whatever it wants to do with it. So I'll change the signature of this method to now take in runs, wickets, and overs. So now what I'll do is that I'll come here and I would say that I would do run rate board dot update the value of runs, wickets, and overs. Do you see what has changed? The only thing that has changed is the flow of data. So instead of previously it was being pulled, now it is being pushed. So of course, now I can get rid of all this mess that I had created here. And all that I'll do is whenever it happens, whenever this method is called, I can have a piece of code that updates the run, wicket, and overs, and then persist that into database. So this is one thing that can be done. This is definitely an improvement. So this solves that performance wala problem where the while loop was running again and again. But do you see some design problem with this? Do you feel that the solution is not so scalable from the perspective of low-level design? What is it which you still don't like about the current implementation? Come on, tell me. Run rate board is a concrete class. Yes, very good. Do you guys remember open closed principle or dependency inversion principle? Okay, so have we been talking about this thing right from the beginning, that a class should not depend upon a concrete class. It should only depend upon an abstract class or an interface. Why? Because think of it in this manner. Right now, you just have one subscriber to which you are vending your data, to which you are pushing your data. Now, tomorrow, if you need some other subscriber, you will have to perform the code change over here again. So imagine there is a projected scoreboard. There is a projected scoreboard. This is another subscriber that you have. So in order to send the data, you would definitely want to make code change here. You would want to have an instance of projected scoreboard. Okay. And you will have to basically get that thing in via constructor. And you'll have to do projected scoreboard dot update runs, wickets, and overs. Do you realize one thing, that as the number of subscribers grow, the code written here will be growing. This class will end up depending on too many concrete classes. So that is the problem. Is it clear? How many of you are able to understand why this is a problem? Okay. How do we solve this problem? Whenever we see that there is a class which depends upon a concrete class, or which depends upon too many concrete classes. Did you see that something like this happening in case of ATM design also? Like in ATM, we saw that there is different behavior in different states. So what did we do? We took that state thing out and we made that state thing as a abstract type. And then we made this thing depend upon that abstract type only. See, update method is going to be common for all the subscribers that you have. Do you agree? Yes or no? It's the same update method. I mean, the signature of update method, the data that it takes is going to be the same. It's the same update method that I have written here in run rate. And it's the same update method that I have written over here in projected scoreboard. So why can't I do one thing? That I probably create an interface which has that update method. And now those concrete classes can probably implement that interface. Do you see the point that I'm trying to say? So this gives rise to the need of an interface that we can probably create and get our job done. Okay. So I can imagine that we may have a very simple interface here. We'll call it as subscriber. And that subscriber interface will have some method inside it. So if I have to implement it in that mode, I would say, let's go ahead and create something called as subscriber. So there is an interface called as subscriber, as you can see, and it has an update method inside, okay, which takes these three things. And now you can see that there are multiple concrete classes that implements this subscriber. For example, there is a run rate display subscriber. So there is a run rate display subscriber. And what this run rate display subscriber does is it has that update method. And inside this update method, the logic is to set runs, wickets, and overs to the latest values that are passed from the publisher. That is what it does. And after that, it can do some other things also, whatever it wants. Let's say it wants to persist that data in database or whatever. So you can see that all the concrete classes at the end of the day are implementing a common subscriber. Okay, there is a common subscriber. Now, what do you think? So I have a notion of an interface called as subscriber. I can also have notion of an interface called as publisher. Why? Because think of this in this manner. Let's say you are trying to build your own software that basically subscribes itself to multiple channels, that subscribes itself to Hotstar, Sony, and multiple other channels. And from wherever it gets the latest data, because we don't know that which of these networks would be running faster. So from wherever it gets the latest data, it pulls that data and basically displays it. So it can happen that as a subscriber, I am subscribed to multiple publishers. It can very well happen, right? So there is a need of publisher interface also. So what I'll do is I'll create a publisher interface. And now you can think about it. So if you remember the cricket scoreboard class that we had written, we saw that there would be multiple subscribers inside it. So the first thing that comes to your head is that, hey, I'm going to have a list of subscribers inside my publisher class. Okay. So I have a method called as subscribe. When this subscribe method is called, then this subscriber will be added to our list of subscribers. Similarly, when unsubscribe method is called, then this subscriber will be unsubscribed. So this facility should be offered by a publisher, isn't it? I mean, if you get a lot of mails from some place and you as a subscriber want to unsubscribe, then that facility should be there. On the other hand, if your friend gets mails from somewhere and you want to probably subscribe to it, that facility also should be there. So two very important methods for my publisher is subscribe and unsubscribe, so that the subscribers can basically choose to get themselves added or deleted. And there is one more method called as notify subscribers. So notify subscribers method, what it does is, you can imagine what it does. See, every publisher will have a list of subscribers that it needs to notify. So in notify subscribers, what it can simply do is it can iterate on the list of subscribers and simply invoke subscriber.update. And that's it. I'll show you an implementation. So Cricut Scoreboard Publisher is an implementation of our publisher interface. And you can see it has a list of subscribers. And what is the type of subscriber? Is subscriber an abstract type or concrete type? What is it? It is an abstract type. Because it is an abstract type, so it means that inside this list, I can have a run rate board also. I can have a top discussions board also. I can have any other board. I can have any form of subscriber that implements this thing. Okay. So yeah, now you can see, you can look at the code that is there. So we say, if somebody has to subscribe, then we basically add that subscriber to the list that we have. And if somebody has to unsubscribe, in that case, we remove that from the list. We remove that subscriber, as you can see, from the list. Now there is a method called as notify subscribers. So this method is called with the latest data. So the first thing that we do is we update our data, and then we simply iterate on the list of subscribers. And on each subscriber, we call update method. You remember this thing, right? In subscriber interface, we had a method called as update, to which we could pass runs, wickets, and overs. And that is exactly what we are doing to each member of the list. Do you see how convenient it has made things for us? Because tomorrow, if you need to introduce a new form of subscriber, then this class is not going to change. This method is not going to change. Okay, you just have to add that to this list by invoking this method, and the notification will be sent to it like a charm. Okay, so far, is it making sense? How many of you are getting hold of all these things? You can type in yes or no. So we have a publisher interface, we have a subscriber interface. Okay, I'll also tell you one thing. This pattern is called as observer pattern. This is not called as publisher subscriber pattern. Why? Because there is a separate publisher subscriber pattern, which is slightly different than this, but I'll not be talking about it. This pattern is called as observer, but the nomenclature that I have chosen it just for your convenience of understanding. Some people call it as observer and observable, which, I mean, is little counterintuitive at times to disambiguate them, that what is what. So I'm calling it as publisher subscriber for now. Okay, so now that we know why we have publisher interface, why we have subscriber interface, and what is the method that we have inside subscriber interface, what are the methods that we have inside publisher interface, we can think more. We can think more from here onwards. Tell me one thing. Don't you guys feel it that the data which is there inside a publisher, runs, wickets, and overs? So listen to me very carefully. It's an important point, and I want the answer to come from your side. Do you think that all the subscribers of this publisher will be requiring all the data? No. Can you tell me which subscriber out of projected score and run rate will not be requiring all the data? If you have to compute the run rate, can I say just the runs and overs is enough? Think. If I just know how many overs have been bowled and how many runs have been scored, I can compute the run rate. So what I am trying to tell you from this trivial example is that you may have multiple subscribers, but not all the subscribers would need all the data. So if you are sending all the data to all the subscribers through the network, then you will be consuming a lot of network bandwidth in that case. If all these things were actually happening in a production scenario where the subscribers were deployed on different servers, then you would be consuming a lot of network bandwidth. So instead of, just think of it in this manner. Let's say I have subscribed myself to a Medium blog, but I'm only interested in computer science blogs. And now if it starts sending me the Bollywood blogs or anything like that, then I'll not be interested in it. And why should it send so much data to all of its subscribers? It should be left on subscriber to consume whatever they want to consume. Do you see what I'm trying to say? Is it making some sense logically? You can just type in yes or no. So how to do that? How to ensure that we are able to do anything like that? Tell me. Think of it in this manner. Right now, okay, so can we have a subscriber type? If you mean any enum type or something, then that is again going to be unscalable, because then every subscriber is different. I mean, the publisher will not be able to, I mean, publisher will have to probably use some if-else conditions to figure out that which data is to be sent to whom. And so if you are thinking in these patterns that, let's say inside subscriber interface have a method called as get type, and it returns a certain enum type, which says that it is a run rate subscriber, that is that subscriber. So even if you do that, then inside here, you will have to write if-else conditions. So you will have to say something like this. If I'm writing pseudocode, if the type of current subscriber is equals to run rate, if this is the case, then only send so-and-so data. If that is the case, then only send so-and-so data. So if you are planning anything like that, then that is going to introduce if-else conditions over here. Okay. Do you see the point that I'm trying to say? So that is not going to be a scalable solution. Another thing, that because all these subscribers are coded against the same interface, so they have the same method. They have the same method signature, which always takes runs, wickets, and overs, right? But if you have to think about the logically senseful signature for, let's say, a run rate subscriber, then what would it be? You would just want to pass around the runs and overs, not the wickets. So it looks like that different subscribers need to have different methods. What I would say that relax. Don't pass anything around for now. This is what I would say. Now, whenever update method has been invoked on a subscriber, then what that subscriber can do is it can pull the data which it needs. Do you see what I'm trying to say? Now, the publisher will simply knock the door. It will simply say, hey, something is updated. It will not pass anything. And now, because if update call has been made on a subscriber, that means something must have been updated at publisher end. So now what this subscriber can do is it can pull the data from there. This is all that I'm going to do now. Is it making sense? Just type in yes or no if you get that. So in order to do that, what I can do is, let's say we have a run rate display subscriber. I would say that every subscriber can contain a reference to the publisher also. And because this publisher again is an abstract type, so it's perfectly okay to do that. Okay. So it can contain a reference to the publisher to which it has subscribed itself. Now, whenever this update method is invoked, then the logic over here would be something like this. I would say that, hey, what am I? I am run rate subscriber. So what do I need? I just need to know the runs and overs. I don't need to know wickets. So let's remove this. So I would simply say that, hey, my runs should be made equals to, because I have a reference to the publisher. So I can simply say publisher dot get runs. But now we see that this get runs method is not implemented inside this interface. So for that, what we can do is we can just go ahead and do that. You see it, right? Only the methods that are described inside this interface, only those can be called by the outside world on a type of publisher. So I can just write a method called as int get runs. Okay. And now this get runs method, if you remember, it is already implemented here. Similarly, you can have int get wickets. And you can also have the last one, which is float get overs. This is what you can have. And now this all simply means that inside of this, we can say publisher dot get runs, right? And in order to get overs, we can say this dot overs equals to publisher dot get overs. And now you know the runs, now you know the overs, so you can run your algorithm to figure out the run rate and display it or persist it or do whatever you want. So what do you think? Okay, first of all, did you understand like how this design is different than the previous design where we were sending everything to the subscriber? Make sense? Yeah. Okay, cool. So this way you can code all your subscribers Okay, subscriber will have, it'll point to the publisher to which it has subscribed, and from there it can get you can think of it as a mix of push and pull, but here the subscribers are not pulling in a chicken-headed manner. So earlier they were, just running and pulling, running and pulling. Now only if they are notified, then they are pulling. Okay, so it's a mix of that, and it's much more sensible than whatever we saw earlier. Cool. One more thing. See, the relationship from publisher to subscriber, what kind of relationship would it be? What do you think? One to one, one to many to one, many to many, which kind of relationship? Many to many, isn't it? See, a subscriber can subscribe itself to multiple publishers. Similarly, a publisher could be subscribed by multiple subscribers. So it's a many-to-many relationship. I can say that I, as a subscriber, I have subscribed to publisher 1, 2, 3, right? And publisher 1 can say that, hey, my subscribers are subscriber 1, subscriber 2, subscriber 3. So it's a many-to-many relationship that is out there. So the way you had kept a list of subscribers inside this Cricut scoreboard publisher, you might also want to keep a list of publishers over here, because I even gave you an example. Let's say you are writing your own software that contains the latest run rate of the match that is currently going on. Then in that case, you might want to subscribe yourself to multiple publishers, right? So you can say that, hey, what I'll have is going to be a list of publisher. And one of my publisher will be Hotstar, another publisher could be something else, then another publisher could be something else. But what is for sure is that I'll keep myself subscribed to multiple publishers. Now let's see what changes will be made as a consequence of that. It's very simple. We can just do that. New of array list, some list. Okay. Now, whenever this update method has been called, will there be a problem thing? Will there be a problem in this implementation? Whenever update method will be called, will this subscriber be able to figure out that from which publisher it has to pull the data? No, it won't be able to do that because it is subscribed to multiple publishers. So it does not know which publisher currently invoked this update method. Do you see the problem here, the underlying problem here? Just typing yes on others. It's a common sense. I mean, somebody knocked your door, but you don't know who knocked your door. So how to fix this? There is a very simple fix to it. Tell me. Yes, we can just pass the publisher instance also. Imagine if I once again go and further improve my signature and say that, hey, this time the publisher who is publishing would also pass itself, pass its instance by this. Okay, so whenever it passes its instance, then the job is done, isn't it? Because now what will happen is that now no problem. Now I don't need to actually figure out that which publisher it was that had called this method. Whichever publisher calls, it passes its instance, and I can just use that. Is it making sense? How many of you are getting this? Yeah, so this is one change that you can probably make. So did you see that we started off with very simple interface where initially we were taking runs, wickets, overs, everything. And then we decided, hey, we will not take anything. We will just pull the data. And then we realized that, hey, because it's a many-to-many relationship, because of that, there can be multiple publishers also. And if you are not taking any data, then you don't know who is sending that data. So we said that, hey, we will take in that publisher argument also. So the point that I'm trying to make is that the interface definition that you come up with the first time might not be the best one. When you pour some head into it, when you use some brain, then it refines more and more with time. See, a new guy, a beginner, won't be able to come up with something like this in the first go. You will always be able to come with the brute force implementation where you are passing everything and then you decide that, hey, this can be better, this can be better, this can be better. But if, as a learner, if you look at this thing as the first thing, then you will not be able to appreciate why this is the most sensible thing. So, it always makes sense to start from the brute force solution. Then only, when you reach at the top, you feel that, hey, this is the most elegant one. If I had showed you this thing to start with, then you might not have been able to appreciate it. But now you can appreciate that, yeah, this probably is the best signature of your interface. Is it making sense to everyone? Yes or no? Cool. So yeah, this was the observer pattern. Today, when you guys go back, try to take out some time and watch the video on stock trading app. So we have just created a very simple application for stock trading. It's there on your dashboard. So we have made use of observer pattern there to solve a very simple problem. Okay, so you can just take a look at that if you want. Now, let's think about few more things here. So right now, I mean, we have been able to write a code where there is a many-to-many relationship from publishers to subscribers. Now, one more thing. Let's say there is a subscriber called as top discussion subscriber. And now this subscriber wants to show the top discussion for an ongoing cricket match also, and for an ongoing football match also. So let's say there is football match between Barcelona and some other league, whatever. And this top discussion subscriber should basically contain the latest score of that. That the score is 3-2, and the minutes elapsed is, let's say, 25 minutes or whatever. So in that case, what comes to your mind? So because I have a common publisher interface, can I use this interface to publish football match ka data also? What will be the data of football match? The data of football match would be, goals, goals 1, goals 2, minutes elapsed. Let's say these are the 3 things for now. Let's keep it simple. What will be the problem with it? Let's say you realize that, and now you say that, hey, I'll write a class. The name of that class is football publisher. And I'll make this thing, I'll code this thing against my standard publisher interface. Let's say this is what you have done. It's nonsense. Why is this nonsense? Because as you are implementing publisher, you will have to implement get runs, get wickets, and get overs. Do you see the point? Does it make sense for football class to implement these methods? Yes or no? Just think and say. It makes no sense. But the way you have designed your publisher, it is forcing your football publisher to implement those methods. Yeah, in the worst case, what you can do is, in the worst case, you can say that, hey, it's a poor design. It's a poor design. So I can say that, hey, whenever get runs is invoked on an object of football publisher, I would throw an exception. I would throw a runtime exception saying this operation is not allowed. Okay. And I'll do the same thing for all the other methods also. But this is bad. This is so bad. You imagine yourself as a developer who was asked to write a football publisher, and you found out that the legacy interface that we had, that interface forced you to implement these methods by throwing exceptions. Would you be happy about it? Would you be contented about it? No. This is design of a poor pattern. Furthermore, you would say that, hey, when I talk about football score, then in that case, I'll have to vend out the goals. So inside this publisher, I would want to write a method called as int get goals 1. Similarly, I'll have to write int get goals 2. Now, because you have written these methods here, so you will have to implement it here inside your football publisher. But the worst thing is that, hey, you have forgotten your old friend, cricket, that also will have to implement these methods. And now because it's nonsense for cricket to vend out these things, so this cricket will also have to throw exceptions for such scenarios. Do you basically see the point? The point is that if ever it happens that your class has to do compromise by implementing an interface, then it basically means that interface is not good. I mean, that interface is bulky. It simply means that interface is bulky. So here we use a very beautiful design principle to get rid of this thing. What is that design principle called as? Anyone who has studied that, who knows it? Interface segregation principle. Today, when you go back, look at the dashboard and go through interface segregation principle and try to understand how interface segregation principle allows us to take care of problems like this. So I'll tell you the essence of interface segregation principle. No, single responsibility principle is different. So there are 5 design principles, solid. S is for single responsibility, O is for open closed, L is for list proof substitution, I is for interface segregation. And that is what I'm talking about. Interface segregation means that whenever you build a bulky interface like this, it means problems like these will arise, whatever we have seen now. So in order to take care of that, you should segregate your interface. So it means what I can do is I can write a separate interface called as Cricket Publisher, and I can write a separate interface called as Football Publisher. Similarly, I will write a separate interface called as Cricket Subscriber, and I'll write a separate interface called as Football Subscriber. This is going to solve the problem completely. Is it making sense? How many of you are getting a feel of how this will solve the problem completely? Yeah. And the idea behind this is of interface segregation. Break a bulky interface into multiple smaller interfaces. That's the idea. So when you go back, just watch interface segregation principle in the design principles part. If you have time, please watch all the 5 principles. That will be a good refresher for you. Then watch the video on observer pattern that's there on your dashboard, and also watch the stock trading app. Do this much at least for today. Okay. And then that will be enough. Cool then. So I think that will be it. Let's meet again tomorrow for the last design pattern that we wish to cover. Okay, cool guys. That's it. Bye and good night.